Good morning, boys and girls, or good afternoon, or good evening. I hope that you're enjoying your day off today. It is too cold to go outside, and we'll just have to wait and see if we have tomorrow off from school. But since we have some time off, I thought it would be good to review with you some information that we've studied uh, in science class. One of the things that we recently studied was magnetizing, or magnetization. I wanted you to learn what magnetizing is, and I wanted you to learn what occurs inside a ferrous object. We studied that a ferrous object, such as a paperclip, a tweezers, or an iron nail, is an object that has iron-like properties. You notice that all these three things, the paperclip, the tweezers, and the nail, they're all what's called ferrous. They all have iron-like properties. And we're trying to learn what magnetizing is. And I told you that this IZ ending, eyes, the suffix means to make or to become. So if we were to use that information and say, what does it mean to magnetize, if the IZE ending, or the eyes suffix, means to make or to become, to magnetize would mean to make or become a magnet. And that's really what we're doing here when we magnetize any of these ferrous objects, or any ferrous object. When you magnetize it, you're really turning it into a magnet. And there's actually a name for that. That's called a temporary magnet. So what I want to do today in this video lesson is turn a paperclip, a pair of tweezers, and a nail. I want to turn them, or any of these ferrous objects, or objects with iron-like properties, I want to turn them into temporary magnets. Let me show you, and you've seen this before, what each of these ferrous objects look like when they're not magnetized. First of all, let's look at the key. The red indicates the North Pole. The red square and the green square indicates the South Pole. You can imagine this as any of the ferrous objects. This could be the paperclip, this could be the tweezers. There's two of them here. Okay, so what we have, let's say that this is the paperclip and this is the tweezers. In this paperclip on the left-hand side, you'll notice that the north poles, which are red squares, are all facing in different directions. This north pole's facing that way. I'll even get an arrow to show you where some of these are facing. Got that north pole facing this way. This north pole's facing that way. That north pole's facing this way. You see this north pole facing that way. This facing this way, this facing that way. None of these north poles are truly facing north. And what's interesting is that none of the north poles are facing the same direction. Take a look at the south poles. Let's take a look at the south poles. South poles in this paperclip, all facing different directions, and none of them truly facing south. So that's in the paperclip. Look at the tweezers. You have south poles facing all sorts of different directions. And this is in a tweezers, a ferrous object that's not been magnetized, or has not become a magnet. Same thing with the tweezers north poles. The north poles all face different directions. What you want to do when you magnetize a ferrous object is get all the poles to face the same directions. The magnets that are on your fridge, the magnets that you use in class, the magnets that you have at your desk, or the magnets that are in certain devices, their poles, they're all aligned, and all the north and south poles in those permanent magnets, we call those permanent magnets, those poles all face the same direction. I'll show you here. So what we do is, well, what I'm going to do is I'm going to take a magnet. I'll create a magnet actually right in front of you here. I'm going to make a bar magnet. Okay, and you saw me demonstrate this in class. I'm going to give it a north pole here, and then I'm going to give it a south pole on this side. I'm going to group this so it's one magnet. What I'm going to do now is take this magnet. So what I'm going to do is I'm going to magnetize each of these magnets. Let me show you how I'm going to do that. And you saw me do a demonstration of this in class. But what I want to do is I want to align the poles. That's really what I want to do. I want all the north poles to face north and all the south poles to face south, and I would just magnetize it like this. You'll notice that I'm sweeping the ferrous object, the tweezers, with the bar magnet in a very straight line, because I want all those poles to be straight and to be aligned. I would do that with a paper clip. 2, along with the tweezers, another ferrous object, the paper clip, lay it flat, and try to sweep it straight so that the poles are all aligned and that they are straight. Just like this. And then what you see is this. In magnetized objects, such as magnets on your fridge or the magnets that you use in class or any magnets that are in tools, the poles are all facing straight. Or the poles are aligned and facing the same direction. Look at all the north poles facing this way, facing north, and all the south poles are facing the same direction as well. And that would be in the paperclip and in the tweezers. All the north poles facing one way, all the south poles facing the same way as well. So if you just look at this visual briefly, in a non-magnetized ferrous object, there are poles. There are north poles and there are south poles. In a magnetized ferrous object, there are poles, there are north poles, there are south poles. It's just that in the magnetized object, whether it's a temporary magnet, meaning whether you've turned a ferrous object into a magnet temporarily, or whether you have a regular magnet, the difference is that the poles in a ferrous object that's not magnetized are not aligned and face different directions, and the poles in a ferrous object that is magnetized are aligned and they face the same direction. So just consider this visual when we're thinking about magnetized ferrous objects, permanent magnets, and non-magnetized ferrous objects, temporary magnets. Thank you.